And now it says that it's revolved about the line y equals 1, which is this line. So instead of this going around the x-axis like we're used to, it's now going around this line. And so instead of the radius just being our function, the function just used to be our radius, but now our radius is going to be something different. And the way we figure out radius is it's always the distance from the center of your circle. You know, if you're thinking about a circle, the radius is always the distance from the center to the outside. So if you think about this, if we're spinning around this, that means that this is the center of any of these circles that we draw. And the radius is going to be these different lengths. So no matter what they are, it's going to be from here to here, which we can simply represent as taking the top minus the bottom, which in this situation is 2 minus x squared minus 1. So I'm going to do a little bit of cleaning up here, and so 2 minus 1 is 1, and I can just write 1 minus x squared. So that's going to be my radius. So when I go in and I say volume is equal to pi r squared h, the pi will be out front, and we'll go from, I don't know the bounds yet, but we do know that it's going to be 1 minus x squared dx. So now we just have to find the bounds. And the bounds are on the tail ends of our shaded region, which is here and here, or put when that and that are equal to each other. So when 2 minus x squared is equal to 1. So if I go and I solve that for x squared, we'll solve it for x, I'll subtract the 2 from both sides. I get negative x squared is equal to negative 1. Divide by negative 1, I get x squared is equal to 1. And we'll just take the square root of both sides, and we'll get the x is equal to plus or minus 1. So those will be my bounds, because the x values of my intersection are 1 and negative 1. So now that I have this integral, I can set it up. And I can go in and just evaluate it. So let's see, negative 1 to 1 of parentheses 1 minus x squared, close of parentheses squared, dx. So I got that, which I'm going to convert that to a fraction, because that has a repeated decimal. So 16 over 15, and don't forget the pi. So 16 pi over 15. You know, and it's volume, so if there were units, it'd be units cubed.
Mr. Canfield, you have a chart.
Oh, sorry for the jump cut. So in this one, let's see, we got the line y equals x. I'll draw it up here this time. So we got the line y equals x, which is going to be our diagonal. X equals 6, which is over here. Y equals 4, and y equals 1. And so if we look at the region that's enclosed by those 4 lines that we just drew, this region's enclosed by those 4. And it says we're rotating about the line x equals 6, so that's saying that we're rotating it around that line. We're rotating it sideways or horizontally. Because we're rotating it that way, we know that our integral this time is going to need to include a dy at the end. So we know that, and we know that we're going to need to go from a low y value to a high y value. And so if we look here, the lowest y value is this lower line, which is y equals 1, and the high one is y equals 4. So I know that my bounds are going to be from 1 to 4. So now I just got to figure out what my radius is going to be. And like we said before, our radius used to just be, you know, whatever it was from the center axis out here. But since we don't have that, since our spinny thing, since our axis is out here now, and we're rotating this around it, these different things here are going to be our different radii. All right, I almost forgot to click record. So each of these are going to be radii, and since we're not going up to down, we can't do top minus bottom. Since we're going this way, we want to do right minus left. So on this one, our radius is going to be right minus left. And that goes for if this line was after it, it would still be right minus left. So in this case, the vertical line is the farthest right. So we would want to do x equals 6 minus the left, which is, I don't want to put x here. Remember, I need everything to be in terms of y's. So instead of saying y equals x, I'm going to use x equals y. So 6 minus y is going to be our radius. And now I can go to my calculator and two ways you could type this in, remember. You could type this in 1 to 4 of 6 minus y. Oop, forgot the parentheses. So instead of me having to type the parentheses into 6 minus y, like instead of having to do all that, there is a shortcut here that our calculators have as a capability. And that's called the insert function. It's right here, INS. If I push second and then that, it changes the cursor to this blinking blank, and I can do a parentheses, or really whatever I want. I can type as many things as I want, and it'll work more like a keyboard, where on a regular computer, how it'll just kind of put things in front of it. But then I got to put another one after it. Oh, I guess it gave me a spot there for it, squared. But if it didn't, I could do the same thing of using the insert function. Let's see, dy. Okay. So I got 39, so 39 pi would be our answer for this one. And just, seriously, instead of using y's, if we had just in the calculator typed x anytime we saw a y in our setup, we get the exact same answer. So it's irrelevant what letter you use. But I know for some people they'll be more comfortable one way or the other. All right, let's keep going. Oh, that's the end of the disk method.